Hello students, on behalf of Rayat Shikshan Samstha's Rayat Online School Education, that is ROSE project, I welcome all of you to SGM College Karad. Myself Shubhangi Jadhav. Today we are going to learn the new chapter in chemistry. This is the first chapter of chemistry textbook named as Solid State. In state board exam, the weightage for this chapter is of 4 marks without option and 6 marks with option. Now see the contents in this chapter. Here you have to learn 10 main points. The first one, introduction. Second, types of solids. Here you have to learn two types of solids named as crystalline solids and amorphous solids. You have to learn also two important phenomena related to these two types of solids named as isomorphism and polymorphism. The third point, that is classification of crystalline solids. The fourth one, crystal structure. Then cubic system, packing of particles in crystal lattice, packing efficiency, crystal defects or imperfections, electrical properties of solids, and magnetic properties of solids. Students, this syllabus is also included in the exams, that is NEET, JEE and MHT-CET. Okay, and therefore this is very important chapter, but this is very interesting and easy chapter. Now, this is our first lecture, and hence we are going to learn here only 3 points, that is introduction, types of solids, and the phenomenon named as isomorphism and polymorphism. Now, if you see your textbook, every chapter includes the session named as Can you recall? Here, in this session, few questions are asked to you in order to recall your memory or to check your previous knowledge. Our chapter Solid State also starts with this session, that is, Can you recall? Here two questions are asked. Let's see the first question. What are the three most common states of matter? I know you quickly give the answer as solid, liquid, and gas are the most common states of matter. But do you know that matter may also exist in two more states named as plasma state and Bose-Einstein condensate? Here, out of these 5 states, the first 4 states are natural and the fifth one is man-made. But though the fourth state, that is plasma state, is natural, it does not occur on the earth. Generally, it occurs at sun and stars, and therefore the most common states of matter that exist on the earth are only 3, named as solid, liquid, and gas. The second question, how does solid state differ from other two states? You have to answer this question with reference to volume, shape, effect of temperature and pressure on these, and the motion of constituent particles and interparticle forces. That is, here you have to answer this question with the help of general characteristics of these 3 states. You studied these general characteristics in 11th standard in the chapter named as States of Matter. So today I will just revise these characteristics with the help of this picture and a video clip. Now see, here this picture shows the matter existing in 3 states, that is gaseous, liquid and solid state. This is a macroscopic view of the matter. Here you will observe small spheres in this picture. These small spheres are nothing but the constituent particles present in these matters. Okay, here The constituent particles means atoms, ions or molecules. In this chapter, you will frequently come across this term, that is constituent particles or simply the particles. So remember well, the constituent particles or particles are nothing but atoms, ions or molecules. Now observe the interparticle distance in all these three states. Okay, here in gaseous state you will observe that the interparticle distance is very large. In liquids, the interparticle distance is comparatively small than the gases, but it is large than that of in solids. That is, there is a moderate interparticle distance in liquids, while in solids, the interparticle distance is very small. Here, the particles are very close to each other. And due to this interparticle distance, here you can observe that in the gaseous state, the interparticle forces of attraction are very weak, while in liquids, the interparticle forces of attraction are moderate, while in solids, they are strong. And due to these interparticle forces of attraction, here you will observe that the particles in gaseous and liquid state are in continuous random motion. They possess both translational and rotational motions along with the vibrational motion. But the particles in solid do not possess either translational or rotational motion. They possess only the vibrational motion. Here, due to this, the particles, the matter existing in gaseous and liquid state is having different shape. It occupies the shape of the container in which it is placed. Now see the vibrational motion of the constituent particles in solid state. Here you will observe that the particles are vibrating along a fixed mean position. Okay, and due to this, here the particles in the matter in the solid state is having definite volume, definite shape, and it is also non-compressible, that is it is rigid one. Now with the help of these observations you can easily differentiate between these three states of matter. Okay, so let's see the distinguishing points between solid, liquid and gas. I have given you here the table which gives us the differences between these three states. Now see the first point, shape and volume. Solids are having definite shape and volume. Liquids possess definite volume but different shape. Gases possess neither definite volume nor definite shape. The intermolecular space is very small in solid, moderate in liquid, and large in gaseous state. Therefore, the interparticle forces of attraction are strongest in solid, moderate in liquid, and very, very weak in gases. We have seen that the particles in solid state cannot move freely. In liquid state, the particles can move a small distance within that liquid, while in gaseous state, the particles are in continuous random motion. Now, the fifth distinguishing point is very important, that is the effect of small change in temperature. Here, if we change the temperature of a substance in solid state to a small extent, then you will observe that the volume of that matter changes to very small extent, while the matter in liquid state shows moderate effect on the volume change, while the gases are showing significant high volume change. Now see the effect of pressure. Here, on application of pressure, you cannot compress further the solids. That is, the solids are non-compressible. Liquids can be compressed but to a very small extent. Therefore, the liquids possess small compressibility while the gases can be easily compressed. That is, they are highly compressible. Okay, now with the help of these characteristics, we can easily define the solid as solid is that state of matter in which the constituent particles are held together by strong forces of attraction. Now see the types of solids. On the basis of arrangement of constituent particles, the solids are classified into two main types. The first one, crystalline solids, and the second one, that is amorphous solids. Now, in order to understand these two types, here I am giving you one simple example. See, this is a marble and this one is a chalk. We know that both marble and chalk are having same chemical composition. They are made up of calcium carbonate. That is, both are having the similar constituent particles. But you will observe that they are showing different properties. For example, you know that you can easily break this chalk, but you cannot easily break the marble. Now, the question will arise in your mind that why there is such difference in the properties of chalk and marble, though they are having same chemical composition? Here, the answer is that marble is a crystalline solid while chalk is the amorphous solid. In marble and chalk, the arrangement of constituent particles is different. So, here now we will study the arrangement of constituent particles in both these types of solids. First, we will study the arrangement in crystalline solids. Now observe this picture. Here this picture indicates the crystalline solid. You will observe that the constituent particles in this solid are arranged in a regular manner. Again, there is a regular and repeating arrangement of the particles along three dimensions. That is, we can say that the arrangement of the particles is periodic. Okay, and due to such arrangement of the particles, these crystalline solids are having sharp edges and flat surfaces. They are very close to each other. Okay, now observe the arrangement in all directions. Here this arrangement also extends all over the entire crystal. That is, there is a long range order of arrangement of the constituent particles. Now with the help of this observation, you can easily write the characteristic properties of crystalline solids. See the first characteristic. In crystalline solids, there is a regular and periodic arrangement of particles. Here, this picture again shows you the regular and periodic arrangement of either atoms or molecules. And this picture gives you the arrangement of particles, that is ions, in the ionic solids. This ordered arrangement of particles extends over a long range. See the third characteristic. They have sharp melting point. Due to regular and periodic arrangement over a long range, these crystalline solids possess sharp melting point. See one example. We know the melting point of benzoic acid is 122 degrees Celsius. That is, here at this sharp melting point, the benzoic acid melts. Okay. Similarly, the other crystalline solids are also having sharp melting point. Now, the fourth property of crystalline solids is very important. All crystalline substances except those having cubic structure are anisotropic. I will tell you the meaning of the term anisotropy or isotropy in the next part of this video lecture. Okay, now see the fifth property, that is these are true solids. Now see some more examples of crystalline solids. Ice, salts such as sodium chloride, metals like sodium, gold, copper, and the materials such as diamond, graphite, ceramics, quartz, etc. are the examples of crystalline solids. Now students, see how the question is asked in state board exam on this point. The question is asked as write the characteristic of crystalline solids. This question is asked for 2 marks. In order to achieve 2 marks, you have to write at least 4 characteristic properties of the crystalline solids along with their examples. Okay. Now let's discuss the amorphous solids. In order to understand the amorphous solids, now observe the difference in arrangement of the particles in crystalline solids and in amorphous solids. Here you will observe that in amorphous solids there is a irregular arrangement of the constituent particles, and though in some cases you observe here the regular arrangement, but that regular arrangement does not extend all over the entire crystal, and hence with the help of these observations now we can write the characteristics of amorphous solids. Again you will see one more example, that is of silica. Here, silica exists in 2 forms, named as quartz and quartz glass or glass. Quartz is the crystalline form of silica, while glass is the amorphous form of silica. Now observe the arrangement of constituent particles in this form, that is quartz. Here you will observe that all the particles are arranged regularly and repeatedly. But in the glass, the constituent particles are not arranged regularly. Again, there is not a periodic arrangement of these particles. Thus, here quartz is the crystalline form of silica, while glass is the amorphous form of silica. Now, see the characteristic of amorphous solids. In amorphous solids, there is an irregular arrangement of particles. This arrangement is of short range order. Here this picture also gives you the irregular and short range arrangement of constituent particles in the amorphous solids. Due to this irregular arrangement, they do not have sharp melting point. See one example of plastic. Here we know that when plastic is heated, it gradually and continuously softens and starts to flow. That is, you cannot predict about its sharp melting point. Okay. Now the fourth property of amorphous solids is very important, that is they are isotropic in nature. And the fifth property of the solids, amorphous solids, is that they are pseudo-solids or supercooled liquids. Now, though the amorphous solids look just like solids, actually you will observe that they are not showing some of their properties similar to the solids, and therefore they are named as pseudo-solids. Pseudo means false, or they are also called as supercooled liquids. Okay. Now see some more examples of amorphous solids. Glass, plastic, rubber, tar, metallic glass, quartz glass, etc. are the examples. Now see, In state board exam, the question is asked as write the characteristics of amorphous solids for 2 marks. Now, with the help of these characteristic properties of crystalline and amorphous solids, now we will easily distinguish between these two types. Here, this table gives you the distinguishing points between these two types of solids. The first one, that is related to their definition. See the definition of crystalline solids. The solids whose constituent particles are arranged in a definite or regular geometric pattern in three-dimensional space are called as crystalline solids, while the solids whose constituent particles are not arranged in a regular manner are called as amorphous solids. See the second point of difference, that is crystalline solids possess sharp melting point while amorphous solids do not have sharp melting point. And due to this, the crystalline solids have definite heat of fusion while amorphous solids are not having definite heat of fusion. The crystalline solids are considered as true solids, while amorphous solids are considered as pseudo solids or supercooled liquids. Therefore, here the fifth property of crystalline solid is anisotropy. Crystalline solids are anisotropic in nature, while the amorphous solids are isotropic in nature. In exam, the question may be asked to distinguish between these two types of solids for 2 marks. And to achieve 2 marks, you have to write at least 4 points of differences. Okay. Now see the meaning of the term isotropy. In order to understand this term isotropy, now observe this picture. This picture gives you the arrangement of constituent particles in the solid. Here, observe the arrangement of the constituent particles in different directions such as AB, CD, and EF. Here you will notice that the constituent particles are arranged in a same manner. There is not a regular arrangement of the constituent particles in this solid. And due to this, here if you measure some of the physical properties of such solids like refractive index, conductivity, or thermal expansion, you will observe that their magnitude is same when measured in all directions. And such property to show the similar or identical magnitude of physical properties when measured in different directions is called as isotropy. So see the definition of isotropy: the ability of the solid to show the physical properties like refractive index, conductivity, thermal expansion, dielectric constant, etc., identical in all directions, just like liquids and gases, is called as isotropy. Here, this isotropy arises due to irregular arrangement of particles along all the directions. That is, the magnitude of these properties is independent of direction of measurement. And we know that this irregular arrangement of particles is observed in amorphous solids, and hence all amorphous solids show isotropy. Now, let's study the anisotropy. Here, you observe again the arrangement of constituent particles in this solid along the directions as AB, CD, and EF. Here you will observe that different kinds of particles are aligned in all these different directions, and hence you will observe that the physical properties of these solids, such as thermal expansion, conductivity, or refractive index will be different when measured in different directions. And thus, we can define the anisotropy as the ability of the solid to show different values of their physical properties like refractive index, conductivity, thermal expansion, dielectric constant, etc. when measured in different directions is called as anisotropy. Here, this anisotropy arises due to regular arrangement of particles along all directions. We know that this regular arrangement is observed in crystalline solids, and hence all crystalline solids except cubic structure show the anisotropy. Now, we will study the important phenomenon named as isomorphism. The Greek word iso means same and morphos means structure or form. So here we can define the term isomorphism as the two or more substances having same crystal structure are said to be isomorphous, and this phenomenon is called as isomorphism. Means here if two or more substances have same crystal structure, then they are said to be isomorphous. Here it is not necessary to observe the crystal structure of the substances in order to predict about their isomorphism. Generally, if you know their chemical composition, that is, if you know their chemical formula, then also you can predict whether that substances are isomorphous or not. Here, generally, if the chemical composition of the given substances have same atomic ratio, then they are isomorphous in nature. Now, let's see some examples in order to understand whether the given substances are isomorphism or the given substances are isomorphous or polymorphous. Now see the first example of sodium fluoride and magnesium oxide. Here the atomic ratio is 1:1. There is one sodium atom and one fluorine atom in sodium fluoride. Similarly, in magnesium oxide, there is one magnesium atom and one oxygen atom. Since both are having same atomic ratio, they are isomorphous with each other. See second example, sodium nitrate and calcium carbonate. Here the atomic ratio is 1:1:3. One sodium atom, one nitrogen atom, and three oxygen atoms. Similarly, one calcium atom, one carbon atom, and three oxygen atoms. Thus, these are the isomorphous pairs. See the third example, potassium sulfate and potassium selenate. Here again, the atomic ratio is same, that is 2:1:4. Fe2O3 and Cr2O3. These are also having the same atomic ratio as 2:3, and thus on these pairs are indicating the phenomenon named as isomorphism. Now, but you know that here this criteria cannot be applied for all the compounds. That is, though the chemical composition is having same atomic ratio, all the substances which are having same atomic ratio are not isomorphous. For example, potassium chloride and sodium chloride, they are not isomorphous because their crystal structures are different, though they are having same atomic ratio. So you note down this point. Okay, now we will study the next important term, that is polymorphism. Again, poly means many and morphous means structure or form. So see the definition of polymorphism. A single substance that exists in two or more forms or crystalline structures is said to be polymorphous and the phenomenon is called as polymorphism. Here, the polymorphs are formed under different conditions of solidification. Means during solidification, if there are different conditions of temperature and pressure, then we are getting the different crystal structures of the same substance. For example, calcium carbonate. It has two forms. One is named as calcite and the other one that is aragonite. Okay. The polymorphous form of silica are alpha quartz, beta quartz, and cristobalite. You note down that the polymorphism occurring in elements is called as allotropy, especially if the polymorphism occurs in elements, then it is named as allotropy. Now see some examples. Here, carbon element has three allotropic forms: diamond, graphite, and fullerene. Similarly, sulfur is having the allotropic forms such as rhombic sulfur, monoclinic sulfur, plastic sulfur, etc. Okay, in this manner, in today's lecture, we studied the types of solids, the terms isotropy and anisotropy, and also we have studied the important phenomenon named as isomorphism and polymorphism. I hope you may have understood all the parts in this lecture. Thank you.